Today we will go through the Spring Boot microservices development for a full stack web application. Full stack web application will have three layers. One is the web front end, either using Angular or React.js or even simple web application, good old JSP or ASP or .NET applications. And the back end in the Java world, we could use Spring Boot for microservices development without using the heavy frameworks like Java EE. And the database, the target database that we are explaining is PostgreSQL. So Spring Boot basically provides the mechanism for the updating the tables, deleting from the tables, and inserting into the table, and also provides the way to for the Angular application to interact with the Spring Boot application using the REST HTTP webs like put, post, get, which are the REST web services. So, so in the back end, let us say we have four tables: the equipment table and machine types table. So equipment table means what is in the equipment table? It will have the equipment model number of the equipment, and whether if it is a eBay kind of website, say how many user months, and okay, what is the price and where it is available, like that. And mission types, or what are the different mission types? Is it whatever it is it a tractor or blazer or cedar or whatever it is? Who are the manufacturers? And say, is it David Brown or John Deere or Kubota or Mahindra or who are there, the manufacturers? And models. Each manufacturer will produce tractors and other things, and they will produce in different models: small, big, and large. So our task is here to build a Spring Boot microservice to provide the CRUD operations over these four tables. We could, if you have a IntelliJ, you could generate a Spring Boot project, like it is inbuilt within the Spring Boot initializer. So, within the IntelliJ Ultimate Edition, and you can use the Spring initializer here and add the dependencies instead of example, whatever home equipment is the group, and name of the project maybe say a backend, like that I can give, and it forms the structure for this application. Then what are the dependencies for my my application? So definitely I want to have a REST web service. So web is the dependency, so Spring Web. And also I want the SQL Spring data JPA, and dev tools, Spring development tools, cloud tools, developer tools. Okay, these three. So these three dependencies should be fairly enough to start a good microservice application with using the Spring Boot. Same thing we could do with the Spring initializer over here. So if you are using the Eclipse, so the Spring initializer may not be integrated here. integrated. So you just come to this website and change the group like com dot say form equipment, same thing, whatever the Spring Boot provided. Demo, say here I'm building a backend for my application, and the dependencies. I want a web dependency, say web, Spring Web, and I want JPA, Spring Data JPA, and I want some dev tools, Spring Boot dev tools, three dependencies, and generate, and it will generate a zip file and import that into your Eclipse or even this one IntelliJ you can import. So that zip file comes with a single class backend application and one single annotation, Spring Boot annotation. And the rest of the annotations we added for convenience. So this is a Spring Boot application annotation is a meta annotation interface. Is a meta annotation. It encompasses all these things. Spring Boot configuration, auto configuration, and component scan. So basically, it provides the auto configuration and component scan. So, but here in the application, we want to arrange the different components in a separate package called controllers. So these components generally interface with the front end. So they provide the CRUD operations. So each method will support either put or get or all the HTTP verbs it will support. So either through Postman or from your Angular application, if you want to interact, these are the classes that first gets the control into. So this way, these are controllers. We want to put in a separate package. So we don't want to scan the entire project. So to make it more efficient, it's better to give a sub package for the scanning for the components. The same way, if you want to interact with the database, so we are not going to write any JDBC code or even record sets or anything. Just we will annotate a repository and Spring Boot will auto inject all the artifacts we need. So it is a very high level abstraction for the database interaction. And that is the enabled GPA repository. And then entity scan, when you want to interact with the table in a OR mapping paradigm, you have to create a class for objects, O side. And R side, anyway, table will be there here in your DB database. So R side is covered, and O side you have to create a resource. So these are the three artifacts you need to implement a CRUD operation for a table: a resource and repository and controller. So we arranged in a separate package for those three things. And okay, so if you go back to this, let's go through take a equipment table and walk through that. So first we created the equipment class. All we need to do here is in this resource, go to the table and see what are all the columns are there. Just type those columns as fields in this class. That's what exactly we did. So equipment ID, and modal and user months, user price, JIP, and all these things. And don't forget to generate the setters and getters. Then get and post and get operations will use the getters and setters. And also provide the empty constructor. In nowadays with these IDs, use the generate construct, and you can generate the constructor and also provide the getters and setters and equals and hash code. And it has to implement the serializable. So this one is the entity database. It represents the entity or database table. And what is the particular table name? It will infer the table name from class name, but it's better to give explicitly so that there won't be any confusion for the reader. So just exactly whatever columns are there in your table, put as a database column fields here in the class. And only notable things are in price numeric here in database, but whereas we use the big decimal here. So that kind of very small type mismatches will be there that we have to make a judicious um, we have to choose judiciously the data types. And currency is a character, US dollar, Canadian dollar, the three acronyms. But Java has a currency class. So we use the currency class. Whereas for money, it's not very convenient in Java. So there's no money class that really represents the proper one for the. So I avoided money data type here, even in PostgreSQL as well as the here. So I went with the big decimal and generated the toString. And one more thing, for primary key, you have to annotate the column, which is going to be the primary key. So here, equipment ID is the primary key. So that annotated with ID. And here we set as a auto-generated one. Primary keys for, not for this column. Cancel. Primary keys for the equipment ID here, this one. Constraints identity column. That means it will like a sequence, but you don't have to create sequence and put it here. So that the database itself will give that facility. So it keeps on increasing. So you have to annotate with you have to tell that it is this primary key will be maintained by the um, database. So Spring Boot won't insert any values in that. And generated, and what is the column name? Column name is equipment ID. So that's where we need to be a little bit careful. In Java world, it is a long data type, whereas here it is a big int. So that kind of decisions we have to take. But rest of all generated by the ID. There's nothing much. All we did is just take out the column names and put it here, and identify the primary key and annotate that. That's it. Rest just generate the code, like generate and setters, getters, and everything. So that is, we represented the table in the Java Spring Boot world. Then how do you connect to the repository? That you will provide using the, say, equipment repository. This is also more or less a marker interface we are creating. So we are not writing any code here. Say you have to extend the JPA repository and give the entity name. So here the entity is resources equipment, and what is the primary key? Long. So that's why you have to create this class separate for each table. So here table name and primary key type, both will be there. So you cannot reuse one, you cannot create a one generic one and use for each table. So you have to create for separate for each table. Then comes to the controller. This is where actual coding lies. So for example, I want to interact with this microservice, especially for equipment under host name, then metadata and equipment. Because for equipment table, I want to put the equipment, and for machine mission table, I want to connect with the mission table, metadata mission table. These are all metadata for my project. So for our project. So and that's why we annotated the path with the metadata, with mission type and manufacturer type and model type model. And so these things, uh, and we didn't put a path for the actual mappings at the method level, just only annotated with get. Let's go with the equipment only. Okay. So this is the base path to get to this controller, localhost blah 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 and port and metadata slash this one. And repository equipment repository represents this one, equipment repository, which will help us to interact with the equipment table. That is auto injected by the Spring Boot. Um, So this is a constructor injection. So it will inject the repository into this controller class. Then let's say we are implementing a get interface or get web. Then you just annotate with the get mapping, Spring Boot mapping, and if you put any path here, it will be appended to that path on the top of the class. So right now it is empty. That means the moment you call equipment with the get verb, then the control comes to this method. So all the request headers, the Spring Boot the framework will give as a map to this class. And any path variables, that means after my equipment, if you put anywhere version or anything, that will be filled into this variable. Request parameters are question marks um, within the URL. If you add any uh, what is it variables query params, then it will come as a request parameters. Query param query parameters or request parameters, both are same. Then uh, so because this is a get, we don't send anything from the request. If you want a particular value to be returned, then we could send a primary key, that is, which is nothing but the equipment ID, then find by ID we can use, like say repository dot ID. So we could do that, but right now the implementation is just return everything. That is the implementation, and that's fine. And so we could send the one of them as a equipment ID, like here, equipment ID. We could get it. Say the default is one, and say long is the type ID. We could do that. Then use that equipment ID here to find the particular row and return that. But we want to return all the equipment available within the database. So in the right now in this database, the equipment availables are, say, equipment view all. So these are all the equipment available. So these are all the people who want to sell the items or get the items. So that is the get operation. Now we can do the post, means send the entire new, say somebody wants to sell item, he will enter all his details and okay, I want to put this ad for next 10 days or anything. That the post operation comes here, and whatever the details of that equipment is sent as a body. request body, and we will just save it. So request body, it will create a equipment row and save it here. And same as the patch, the patch mapping. Patch mapping means you can update only one or two fields within the row. That is partial update. Here we are only updating the price, and so if only one or two fields changing, then we use the it's better to use the patch. Say if you want to replace entire record without seeing what is changed and what is not changed, then use the put mapping. And so whatever the new record is there and ID matches, then it will entire row, primary key matches, the entire row will be replaced with this whatever data we send into this body. And we could then delete. So to delete a row, we have to pass the primary key. So we are passing primary key equipment ID as equipment ID, and then delete by ID. So this is how we provide the CRUD operations on the database using the front-end control, REST controller, and taking the support of the repository class, JPA repository class, and resource entities. So let us test through Postman. Say, let's take the example of a get equipment. So I'm blindly getting all the equipment. Oh, server is not running. And let us rebuild the project. I made some changes. We made some changes. Okay, run the project. Let us see whether our Postman works. So whatever is there in the PG admin, the whatever rows we are seeing is coming as a JSON, because the Spring Boot is returning the rows get mapping. Where is this get mapping as JSON by default. So list of equipment, all the rows from this, all the rows from the database, this table are coming as a JSON objects. So that's why we are seeing that as a we are seeing in the output. So all we are sending is in GitHub, there are no queries or anything. So straight away get everything. Now patch equipment. Here we will take here, and the next one is okay, get operation, then post mapping. So let's see, we want to insert a new row. A new row, then what is that? Save equipment. So the new equipment details we are sending in this as a body, a JSON body. So model is 21. That user months is say 12, and user is true, and the price is say 333 and only 50, and zip is certified is false, and country code is US, and state is Texas, and currency is US dollar. We are not giving the primary key, equipment ID. It should generate. Let us see whether it works or not. Okay, it worked. It created a new ID here. It created, okay, whatever the details we sent here came as a request body. Spring has put together and took the entity class here, equipment, and using the setters, it put into that, created a new object and set into that using the setters, and passed that object to this method. So all we need to do is just save that object, and it is, once you save it, it returns the new object from the database using the primary key, because primary key is generated by the database. We didn't pass that. So the returned response from the database or Spring Boot has the equipment ID. So that is now it is 58 because that is a sequence. Now it is running on 58. And go here and 57 is here. So just refresh run one more time. We should see 58 here. So that's how we test from the Postman. Now next this is that is get, and this is a post, that is saving the new thing. This is patch. Say we want to update some price for a particular one, and this is the method. So still the only verb changes. We are maintaining the same URL, because here for patch mapping where the path extension is empty. That means the whatever path is there at the class level, the same path we will use. The only thing is we have to change the verb. So the patch here, patch one, and same thing. And we are sending the parameter as the query parameters, the new value. So the parameter price we are sending as a query parameter. Though request body is here, we are not really doing anything here there. Though it is here. So we could delete that, but so let's not do the experiment right now. And we want to change the price of 41. Do we have a 41 here? Did we delete that? 41 is there. Okay. Let's change the price to 0000. Let's change the price. Yes, price has been changed for 41. Let's go and check. 41 is the 41, the price is 0.0. So that is the patch is working, because we are only interested in updating the price, nothing else. What if I want to update everything? Then I will use the put. So all the new information I get as a request body, and I will save it. So it will find out what is the primary key in this what we are sending. Then it will pick that record and update that record. So the put mapping is put equipment. Here we have to send, we have to give even the equipment ID, primary key, then only it will update. Say here we will update with 00 again, price 0. And what is the primary key? 45. No, this time let us update the 55. So the primary key is 55. Let's update it. 55. Why 55 is not there? This is a put operation. Invalid numeric value. Okay, what is invalid numeric value? Price. Okay, let's go. Now, how do we change this? Price, this one. Okay, let's do put equipment. Okay, now if we put this one, it worked. So why it didn't work the 00 0 0? It worked. Okay, so something with 000 blah blah blah. It is not if more than 10 is not taking. Okay. Okay, will it take after decimal? Okay, it's taking, but before decimal it doesn't take multiple zeros. Okay. So that is the what is it? Put operation. Delete operation. Say I want to delete row 55. Okay, how do I delete? Delete equipment. That equipment ID I am passing here as this one as a query parameter. So params is query parameter. You see here. I don't want this price. I only want delete. So anything appended to this one is a query parameter. So here it comes as a request parameter. Query parameter, request parameter, both are a bit confusing. Path variable is, if anything is this one, these are path variables, if any variable is there. And headers, all headers will come as this one, request header as a map. So I gave the, what is that, from 55, go delete it, 55. The same URL, equipment URL. Okay, it should delete. So 200, okay. And delete, and it's a void method. It doesn't return, and that's good. So what is the ID 55? So my 55 no more should be there here. Okay, 54, 56, 55 gone. So that's how you delete. So that's how you um, implement the CRUD operations. So for each table, those three classes we have to create, and not much coding, and only here just take the fields and put it as with a proper data type, and that's all done. If you have a new table, and do the same thing. For example, say you have a new table here, new table, say test, columns, say, uh, say ID, the not null, and primary key. Data type is, say, integer, and say name, say character varying. What is this one? Say 255. Length. That's fine. Save. Now, if you want to provide a CRUD operation for the test, first you have to create a class here, resource class. Say new Java class test. Implement serializable, I believe. We have to. Okay. Okay. Every class is implementing the serializable. Yes. Implements or extends only possible. Implements and serializable. Start typing serializable. Realizable. That's all. Then basically we have to define the two fields. We have ID field. ID, actually integer is good enough. We don't need ID. And private string, and you have to annotate the ID with as a primary key. Okay, I can do that. ID. Okay, auto generated and all those things, and generate the getters and setters and all those things. Generate getters and setters, and get ID, set ID. What about the name? Why it didn't do that? Getters and setters. Okay, I didn't select everything. Then generate the okay, constructor. Empty constructor is needed. Select none, and also generate the equals and hash code. Okay, that's fine. Both are required field. Fine. So it will generate. So we get done with the resource. Now implement a repository, model repository. It is so new So test repository is the interface. Test repository. Yeah. And what does it do? It extends the JPA repository. Okay. It extends the JPA repository. It represents the test table. Here, this is the click. The proper table name and what is the primary key type, integer. Okay, see, test is uppercase here, but the class that represents the table is test. Give the actual here, the class that represents the table. And import. Okay, and that's it. It is just like a marker. And then you have to create the controller. New Java class, test controller, and provide the what is the controller will have. They have a annotation, and forget to provide the annotations for this controller, otherwise it won't become a controller. So as this one also, annotations are needed, don't forget those. Entity and table name. This is the entity and table name is test. And repository definitely should have a annotation. It's a repository REST resource. So that's how Spring will scan and make it as a injectable repository. Then controller, REST controller, this is a base path, and provide all the getters and setters, get mappings, put mappings, and all that methods. So that's how you implement the Spring Boot CRUD operations in your microservice to interact with the database. Thank you.